Name of God Ram Ram. I'm Kumar K. Previously, I worked at Amazon and Media.net as a software engineer, and now I spend most of my time in teaching and training my lovely students for hard level DSA plus OA plus CP from beginner till advanced level. Also, congratulations to our student for cracking 50 LPSD offer from Amazon off campus. Okay, so I'm so happy that my students are bringing such great results on a consistent basis. Okay, so if you are someone who needs or who wants personalized one-to-one mentoring from me, daily life training from me, and many more features for your placements, be it a working professional or college student, you can check out the link given. So let's discuss, guys, the Codeforces round 1015 division 1 plus 2 problems. So the first problem was this one. Let's check it out. Yeah, max and mod. So guys, they are saying that you are given an integer n. Try to find any permutation p of length n such that this condition is satisfied. Now this is a pretty big condition, right? They are saying that your permutation should satisfy this condition. Now, the actual proof of this can be very difficult, but because this is problem number A, the input and output should give you the enough hint what to do and how to do. Okay, so basically they are telling you that generate any permutation of size n. You know now the meaning of permutation of size n. If I tell you that n is equal to 4, what is the permutation of size 4? Well, you just need to create an array of size 4, and you need to write the numbers 1, 2, 3, 4 in any order in it. Let's say you write 4, 2, 3, 1. So yes, it is a valid permutation of size 4. You guys can see it and observe it, right? Yeah. Now they are saying that please construct a permutation for us. Construct a permutation for us so that if you take maximum of the first number and the second number, na, if you take the, let's say this is the index 1, index 2, 3, 4. So if you take the maximum of the first number and the second number and do it modulo 2, the value should come as 1. Then if you take the maximum of second and third number, if you take maximum of second and third number, and please note that this time the last number is the third number, and you do it modulo with the same index only. You're taking max of second and third number and doing modulo with 3. Can you see this 3 is matching this number? Then the value should be 2. Similarly, they are saying that if let's make n as 5. Similarly, they are saying that if you take, let's say, max of b of 3 comma b of 4, and now you do it modulo 4, the answer should be 3. And finally, if you do max of b of 4 comma b of 5, and you do it modulo the last number 5, index, it should be 4. So how will you generate such a permutation, right? So see, I agree that we don't know the answer, but we know something, right? We know something, right? We know one simple trick, guys. See, the key observation to solve this problem is they are saying that whatever number will come here now, you have to do it modulo 2. Whatever number comes here, you have to divide it by 3. Whatever number comes here, in short, you have to do it modulo 4. Whatever number comes here, you have to do it modulo 5. And the result of modulo 2 should be one number less. 1. Result of modulo 3 should be one number less, which is 2. Result of modulo 4 should be one number less, which is 3. Result of modulo 5 should be one number less, which is 4. So now you only think which number, if you divide it by 2, will it give you the remainder as 1? You want to find a number such that if you divide that number by 2, the remainder should be 1. So the answer is 1 only, na? Why? If you divide 1 by 2, what is going to happen? 2 ones are 2 and then 2 zeros are 0. Like, you cannot actually divide. The remainder will be what? Of 1 mod 2. It will be 1 only. So it is now guaranteed that at this position, na, you can just put a 1. Now guys, you only think which number is possible, like any simple number you guess, such that if I divide that number by 3, I should get the remainder as 2. You are dividing by 3, na? Take a number less than 3 itself. 2 mod 3 is 2 only, because 3 is bigger than 2. See, if you divide 2 by 3, na, it will be 3 zeros are 0, then 2 comes as the remainder. So here you have to put 2. Which number, if you divide by 4, the remainder will come as 3? 3 only. If you do 3 mod 4, it cannot get divided. Full 3 will be left as the remainder. Then which number, if you do mod 5, will it be 4? 4 only. 4 mod 5 equal to 4. So guys, the problem has been solved except the first number. The trick is that from the second index, you have to write this number 1, 2, 3, 4. Like this, you have to write. That's the solution to the whole problem, guys. Hopefully, you enjoyed it, right? So, this is really satisfying and nice problem. So, like, I give you any odd n, na, it will work. For even n, it will not work. That I leave it up to you to figure out. Like, even in the test cases, if you check it out, now you can see in the test cases itself that for even n, na, they are saying -1 as the answer. N equal to 2, no answer possible. N equal to 4, no answer possible. It only works for odd n. Okay, odd n. So guys, let's say n is equal to 7. Now guys, you only use your brain and tell me which permutation will do the job. You know that whatever number comes here, you have to do it modulo 2 and the output should be 1. Whatever number comes here, you have to do it modulo 3 and the output should be 2. Like this, whatever number comes here, you have to do it modulo 7 and the output should be 6. So it's simple na, put here 1, 1 mod 2 is 1. Then put here any number which is less than 3, let's say 2. So 2 mod 3 is 2. Here I will put 3, 4, 5, 6. Because 3 when you do mod 4, it will give you the answer as 3. 4 when you do modulo. If you don't know the meaning of modulo, go and learn it from ChatGPT, AI, Google. Okay. 4 if you do modulo 5, na, you will get the output as 4. 5 if you do modulo 6, you will get the output as 5 only, right? So why is this working correctly? See, at index number 3, they will first, you have to find the maximum of these two numbers. Now you have written in increasing order, na? So max of these two number is this number only. Okay. So this number modulo 3 to this condition is getting satisfied for this index. Max of these two numbers 2 and 3 is 3 only. So condition satisfied for this index also. Max of these two numbers is 5 only. So conditions max of 4 and 5 is this number only. So 4 mod 5 equal to 4. So it is getting satisfied for all the indices. They are saying that the condition should satisfy for all indices from 2 till n. So from 3 till n we are able to satisfy. But guys, what about index number 2? Now you will face a problem, right? Index number 2, they will you have to calculate the maximum of question mark and 1. We have not decided the which number to put at the first place. Whatever is the maximum of this, na, When you divide it by 2, you need the remainder as 1. So guys, see, 1, 2, 3, 4, 5, 6 you have used, only 7 is left. So what if I write a 7 here? What will happen? Maximum of 7 and 1 will be what? It will be 7, and 7 is a odd number. 7 is a odd number. So if this odd number I divide by 2, I will get, if I do mod 2, it will be 1 only. So guys, the solution is, whenever an odd n is given to you, na, what you will do is you will start writing 1 from the second place till n minus 1, and n you will write at the start, and this solves the whole problem brilliantly. This is a very nice brainstorming problem. Even number will never work. Why? Because if you put a even number here, na, like instead of 7, let's say n was 8. If you put 8 here, what will happen? 8 comma 1 maximum will become 8, and 8 mod 2 will be 0, but we want the mod 2 value to come as 1. So you can see and understand this condition as deeply as you want, that okay, for all the indices from 2 to n, make sure the maximum of the current number and the previous number, when you do its modulo I, it should be I minus 1 satisfied. So let's go through the implementation, lovely people. So implementation is here for you. Yeah, so guys, you can see if it's odd, from index, like 1 till n, you fill up the correct places, and the first number should be n, right? Initially the first number I put as 0, then the first number n, and it's done. 5 times RRR, Ram, 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 Ram. Always start everything with the name of God. Then no one will be able to stop you in this life. Okay, guys. Okay. Ram, Ram. Now let's go to problem B, guys. So problem B is also very interesting in itself. Like really, really interesting. So guys, they are saying that we are giving you an array. Tell me if it is possible to rearrange the array in such a manner such that this condition can be satisfied. Now, this is such a deadly problem. 45693. So, guys, this is a deadly problem, but we were able to find its solution luckily. If you don't know about GCD, go and Google about it and try to learn about it. Okay. So, what they're saying is that we are giving you an array. Let's say the array is like 45693. Okay. So, this is the array given to you. Okay. So now what to do after the array is given to you? Just relax, just chillax. Life is a very big gift given to you by God, so enjoy it. So now this array is given to you. They are saying rearrange this array in such a manner such that you can break it into two parts. Like from index 1 to I, and then from index I plus 1 till n. If you take minimum of all numbers from 1 to I, that should be equal to GCD of all numbers from I plus 1 till n. So they are basically saying that minimum of everything from index 1 to I should be equal to GCD of all numbers from I plus 1 till the end. So that is what they are trying to convey to us, and it's really nice to see that. Now, what to do in this particular case? Well, just chillax, just relax. Okay. So, guys, what can you do? How can you rearrange? In this particular question, na, they are saying that we will rearrange this array like this. You should be see anywhere this breakup can happen. You might be thinking that, sir, after rearranging the array, which index I like? I can take this index I also, right? That this first half, minimum of this first half should be equal to the GCD of the rest of the half. Minimum of the first half should be equal to the GCD of the rest of the half. So that's it, right? So you will rearrange the array like this. GCD is the biggest number which divide all the numbers in that set. Like what is GCD of 2 comma 4? Which is a number which can divide 2 as well as 4? 2 is the only number which can divide 2 as well as 4. So GCD is the biggest number which can divide both the numbers asked for. What is GCD of 6, 9, 12? Think about it. Which is the largest number which can divide 6 as well as 9 as well as 12? 3 can divide 6, 9, 12. So 3 is the answer, baby. Anyway, so these things are clear to my lovely students. Life is pretty interesting, I'm telling you. So now what to do? So now what to do? So guys, if you rearrange it like this, na 3, 4, 5, and then 6 and 9, then the problem is solved. Why? You have to decide, you have to cut the array at any particular point, any optimal point. You have to decide that optimal point where you have to do the cutting, okay? You have to decide the optimal point where you have to do the cutting, okay? So let's say this is my optimal point. Then whatever is the minimum of this part, na, it should be equal to the GCD of this part. So can you find such optimal point here? First, given array, you have to rearrange it. After rearranging, guys, this is the optimal point. You break the array here. See, what is the minimum of this part? Minimum of 3 comma 4 comma 5 is nothing but 3. And what is the GCD of this part? GCD of 6 comma 9 is 3. So guys, it is possible. So the output will be yes. So hopefully you got the question. The question is saying that rearrange the array in such a manner such that after rearranging there is a breaking point which can divide the array in two parts, such that the minimum of the first part should be equal to the GCD of the second part. So guys, this is a very complicated problem. In this cases, what should you do? You know, I will tell you the trick. You always try to do some easy observations. Always try to do some easy observations, and they will really make your life easy. All you have to do is just make some easy observations. You only think minimum of some numbers is a easy task, or GCD of some numbers is an easy task. Taking minimum of many numbers is an easy task compared to GCD. So what if you try to divide the array like this, such that the last number you take in the second part, and all the rest of the numbers you take in the first part. So guys, then the problem will easily be solved. You can find the minimum of n minus 1 numbers, right? Minimum of n minus 1 numbers needs to be equal to the last number, because GCD of one number is that only. GCD of 5 is 5 only. So that is the trick, guys. Just make sure now you got the trick, right? The easy observation is that we expand the minimum part and contract the GCD part, and that solves the whole problem 50% actually. So let's say I give you two. Now you only think, you there are 6 elements here in the final array. 5 elements will be here. You will be taking their minimum, and you want it to be equal to this number. So obviously this number will also be the minimum number of the array, right? So what is the minimum number of the array? 1. Write here 1. And rest of the numbers you write here: 2, 1, 3, 5, 4. The condition is satisfied. Why? The minimum of this much part is 1, and GCD of 1 is also 1 only. So both are equal. So guys, when can it happen? When can this condition happen? This can only happen if the smallest number of this array is written here, and the smallest number of the array should be in this part also, because the smallest number is, if it is in this part, then the Minimum of this part will be mean only, which will become equal to minimum of one number GCD is mean only. It means the frequency of minimum number should be greater than equal to 2. The minimum number in the array should come for more than equal to 2 times. Then you can solve this problem, guys. The minimum number should come in the array for greater than equal to 2 times. That is the trick which people were not applying correctly. So guys, can you see in this array 1 is coming for how many times? 1 is coming for 1 time and 2 times it is coming for 2 times beta g. It is coming for 2 times. So what you will do in rearrangement? One time I will write 1 here. My first part is done, and the second part I will write rest of all the numbers. But I will make sure 1 is here also. So this part minimum will be 1, and this is a single number GCD will be 1 equal to 1. So problem solved. But guys, what if the minimum number is only coming for 1 time? Then what will you do? Like this example, 45693. 45693. You know that 3 is the minimum number, right? Let's say you put the minimum number in this bracket. So let's say you know that the minimum of this part will come as 3. But you cannot put a single number. You cannot put a single number 3 here because 3 is coming one time only and you decided to put 3 in the left part. So in the right part, what will you put? The best trick is, see, putting more number in GCD is always a difficult task because we don't know how to deal with the large GCDs. GCD of one number was a trick. Why? GCD of one number is the number itself. So that's why we are putting one number. But now we cannot put one number only. Why? 3 is coming only one time. So you cannot write 3 here and 3 here also. If that was the case, then if let's say there was one more 3, the problem would be solved, right? This one part GCD would be 3 and the minimum of this part would also be 3 and both equal, done. But that's not what's happening. So now what will we do? Will we cry? Will we sit and cry? No, beta G. What if you are able to find a pair x comma y here whose GCD is equal to 3? Yes, you can put 6 and 9 here. 6 and 9 has a GCD of 3. So now you will only put two numbers in the end. See, here you will put 6 and here you will put 9. And rest of all the numbers here. The minimum number also here. So you know the minimum of this part is what? 3. And you know that the GCD of 6 and 9 is also 3. But guys, the lovely question for you is, now the question becomes is that given an array, find if a pair exists, a pair exists whose GCD is equal to x. In our case, x was equal to 3. So guys, how will we know if two elements are there in this array whose GCD is equal to the minimum value of the array? How can you do the trick? So what we can do is, so guys, hopefully you came to know that the solution is pretty simple. If an array is given to you like this, what is the solution? Find the minimum number. Minimum number is what? 3. What is the frequency of 3? 3 is coming 2 times. So if the frequency of the minimum number is greater than equal to 2 times, problem is solved. Output yes. Why yes? Well, you have to output yes because one minimum number you will write here, another minimum number you will write in this part. Now, no matter what other numbers come here, the minimum of this is 3 and the GCD of 3 is also 3. Both are equal, condition satisfied. But Special case is when 3 is coming only one time in the array. What if the minimum number is coming only one time? Then what will you do? Then also the trick is pretty simple, right? This is the array given to you, right? So what you can do, lovely people, is that this is the minimum number, right? So you put in the left part. In the left part there is 3 and some other numbers. You know the minimum is going to come out as 3 only, because 3 is the minimum number. Here you have to put two numbers x and y such that GCD of x comma y comes as 3. So you need to find how will you find the numbers in this array? You have to find a pair in this array whose GCD is 3. So the trick is very simple. If you know the GCD concept, only those numbers can contribute to GCD equal to 3 which are divisible by 3. So let's extract all the numbers which are divisible by 3, but obviously we will not include the number 3 because 3 is already put here in this bracket. So which number is divisible by 3? 4, 5, 6, 9. 6 and 9 is divisible by 3. Now we will actually divide these numbers by 3. So what will happen if you divide them by 3? 3 ones are 3 and 3 twos are 6 and 3 threes are 9. Now guys, can you see this thing? 6 is, what is 6 comma 9? Both have 3 as their GCD, right? Like it is nothing but 2 into 3 dot 3 into 3. Whatever this common number was, I divided this common number from both of them. So now it is 2 comma 3, and 2 comma 3 is co-prime numbers. Their GCD of 2 comma 3 is 1. So guys, if after dividing by 3, the remaining number GCD is 1, it means yes, there is a pair. Yes, there is a pair whose GCD is equal to 3 in this given array. So like I will give you multiple examples, and guys you have to find out if it is possible or not, okay? Let's say I give you an array like this. And the question is there any pair in this array whose GCD is equal to 2? So first what you will do, extract all the numbers which are divisible by 2. So 4 is divisible by 2, yes. Is 8 divisible by 2, yes. So you just extract all the numbers which are divisible by 2. Then 12 divisible by 2, yes. Now I will actually divide them all by 2. So what will happen if you divide them all by 2? This is 2, this is 4, this is 6. What is the GCD of all of them? 2, 4, 6. The GCD is 2, guys. GCD is not 1. After dividing these numbers by 2 now, still there is a common factor of 2 in them. If after dividing them by 2, if none of them had any common factors, like if their GCD was 1 na, it would mean that there is at least one pair of numbers. What I am trying to say is that if I give you like this and I tell you that GCD of x1 comma x2 comma x3 till xn is equal to 1, this means that there is surely a pair in this sequence such that GCD of xi comma xj is equal to 1. This is a very important property. If I tell you that the GCD of a sequence of numbers is 1, it means there exists a pair in this sequence whose GCD is also 1. But guys, here the full GCD of the sequence is coming as 2. It is not coming as 1. It means there exists no pair in this sequence whose GCD is 1. Because no pair exists whose GCD is 1, so if you multiply all of them by 2, reverse the process, no pair exists such that their GCD is 2. Can you see the reverse process? यहां से अपन को ये पता चला कि no pair exists in it such that the GCD is equal to 1. So, because now you multiply all the numbers by 2 and reverse the process, this means no pair exists in this sequence such that their GCD is equal to 2. So that's why the GCD of 2 is not possible. So guys, the solution is pretty simple. What is the solution? You find out all the numbers which are divisible by your minimum number, put them in some other array, find their GCD. If the GCD is 1, yes, it means GCD as minimum number can come. But if the GCD is not 1, then it is not possible. For example, what if you're trying for, let's say, GCD equal to 4? If someone asked you, is there any pair in this array whose GCD is equal to 4? Well, what would you do? You can just relax, right? Just extract the numbers which are having 4 in it, 4, the divisible, then extract the numbers which are divisible by 4. 4 is there, then 8 is there, then 12 is there, okay? Now, like we have extracted the numbers 4, 8 and 12, 4, 8 and 12, 4, 8 and 12, 4, 8 and 12. Now you guys know, na? Divide all of them by 4. 1, 4 twos are 8, 4 threes are 12. What is the GCD of 1, comma 2, comma 3? It is 1. GCD of 1, comma 2, comma 3 is 1. It means a pair exists in this sequence whose GCD of x comma y is equal to 1, and which is true. For example, if you pick up 2 comma 3, its GCD is 1. You pick up 1 comma 2, its GCD is 1. So a pair exists in this sequence whose GCD is 1. Now do the reverse process, multiply by 4. A pair exists here whose GCD is 1. So multiplied by 4, it means a pair exists here whose GCD of x comma y is 4. So yes, a pair exists whose GCD is 4. So guys, that's it. And now if you check the implementation, you will just come to know how interesting it is. Let me show it to you, lovely people. So if I open it up for you people, so guys, you can see it's a simple implementation. You just travel the array, find the minimum number. If the frequency of the minimum number, I hope you know how to use hash map and hashing to know the frequency of the minimum number. If the frequency of the minimum number is greater than equal to 2, well, the answer is yes. But if the minimum number is only coming one time, then all the numbers which are divisible by x, put them in some another array or vector. Obviously, you ignore the number which is exactly equal to x, which is only coming for one time, because you have to put it in the other part. Na? Now, apart from that, and obviously if you put this, then the GCD will be 1 only after dividing by x. But anyways, hopefully you understand why I'm not putting the number x in the storing array, because the number x will go in the left part. Right part we have to find now, that's why. If size less than 2, obviously no, you need more than one number, right, to find a GCD pair. Then guys, you divide all those numbers by x. Then check if this final numbers when all divided by x, do they have GCD as 1? If yes, yes, else no. Done, 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 done. Now problem C is very interesting. Like a few days back, Code Chef asked a similar problem, which makes solving this problem very easy. So guys, they are saying that we are giving you a permutation, two permutations, A and B. And what you can do, beta, is that you can just swap AI with AJ, but at the same time you will have to swap BI with BJ. Determine if A and B can become reverse of each other after some operations. This is a deadly problem, but it's a very nice problem and you can easily solve it, beta G, if you focus on the core concept. Just focus on the core concept. You can do it, trust me. So guys, let me show you 1324 and 2413, or let's say 1221 1221. Okay, so 1 2 and 2 1, only the implementation is very difficult. That you can like check my code when I send you the code. You need to have very deep knowledge of hashing for this problem. Okay, so let's say I give you two arrays, both are permutation of size n. Let's check. Yeah. So they are saying that, like in the problem C, yeah, in the problem C, let me check it up. Yeah, they are saying that this is the first array given to you, this is the second array given to you. This is also a permutation of size n equal to 2, and this is also permutation. Permutation means, you know, na, 1 to n numbers should come in the array and each number should come for a single time. So, like this, you will give your permutations. You have to make sure that array A is equal to the reverse of B. So array is 1 2 and B is reverse, right? 2 1 reverse 2 1. So yes, the problem solved. No operations you have to do, in zero operation you solve the problem. So now what to do, lovely people? It's pretty easy. Like, let's take the number. Let's take 1324. After 1324, let's say 2413. Now this is your array A and this is your array B. Both are the permutations of, size n equal to 4. Okay. So this much concepts you understand, right? Ram Ram. So guys, but you see, this is 1324. This is 1324. What it will be its reverse? Reverse should be 4231, but it is not 4231. So this is not working. They are saying that array A should be reverse of array B. Array A should be reverse of array B. Now, in one operation, what you can do is that you can swap the numbers, guys. You can select any index I and you can select J. Then what you can do? You can swap this number with this number, and simultaneously this number needs to get swapped with this number. So this condition you should always remember in this problem, okay? That when you select I and J, you have to swap AI with AJ, and you also have to swap BI with BJ. So you have to swap AI with AJ and BI with BJ. So how will you do that? Well, that's also pretty easy. But guys, we don't know na which swap should we do so that the equal numbers start coming. So in the actual question, if we see the solution, they are saying that we have to swap one with the two, right? Okay, so let's try that. They are saying that let's swap index number 1 with index number 2. It means this number will go here like this and this number will go here like this. Then what will happen? 1 3 will become 3 1 2 4, and 2 4 will become 4 2 1 3. Okay, so this much you can also observe, I can also observe, and okay, fine. But guys, this solves the problem. In one swap, you solve the problem, baby. How? This is 3124, and array A is 3124, and array B is reverse 3124. A is equal to reverse of B, so it solved the problem, baby. But guys, how will you know that which swap should you do? That is the greatest mystery of all time. Let's say, let's take a very nice example. This is your first permutation and this is your second permutation. This is the permutation A, permutation B. 53124 and 24153. So guys, do you know what is the trick? The trick is this. Whenever you are swapping I with J, you need to observe what is actually happening. Whenever you swap I with J, something special is happening. Guys, AI is getting transferred with AJ, BI is getting transferred with BJ. After swap, it looks like this: AJ, BJ, AI, BI. But guys, there is a strong bonding between AI, BI and AJ, BJ. These bonds can never get broken. Basically, what I'm trying to say is that if in the array it is given that A1 and B1 here and A5 and B5 here, even if you swap it, in the final result, it will show you A5, B5 here and A1, B1 here. Can you see A1, B1 and A5, B5 can never be taken away from each other. They are husband and wife bonds. This is a husband and this is the wife. Indian marriages, long lasting, right? So tricks apart, what I'm trying to say is that there is a bond between AIBI and AJBJ, and that bond can never be broken even when they are transferred. So guys, you can imagine each number as a bond and its reverse bond, and the problem is solved. Dun dun ah, dun dun. What I'm trying to say is that this one, two, three, four, five. This is 5, this is 2. So guys, this is a 5 comma 2 bond. Let's call it as 5 comma 2 bond. Now guys, search for a similar bond in the array. You can search for a similar bond, right? So guys, can you see if you search in the array 5 comma 2 and this is the similar bond here, 2 comma 5 bond. It is just in the reverse order. It has to be in the reverse order or else both the permutations cannot be satisfied. Na? Here 5 can only come one time in this array and 5 can only come one time in this array. So if this 5 is bonded with 2 in the bottom, here it will be upside down nature, na? 2 bonded with 5. So guys, can you see, for there will be bonds like this only. If there is a 5-2 bond in the array, then it is guaranteed that there needs to be a 2-5 bond at some place in the array. Like this. It will always be there. If this is not happening, na, the problem cannot be solved. The answer will be -1, not possible. Opposite bond is needed for this problem to be solved. So guys, by looking at this, what do we understand? To satisfy this phi 2, this 2-5 bond needs to be at the last position, because like a palindrome, this first bond should be equal to the last bond, but the last bond is 4-3. So I will swap 4 comma 5. I hope you guys understood that here there is a phi 2 bond. So you should try to bring a phi 2 bond in the last position also. Why am I saying that? You will understand in some time. Whatever bond is at the first position, na, same bond should be at the last position. But 4-3 bond is coming at the last position. So what will you do? Well, you will just do a simple trick. You will just do a simple lovely trick, lovely students. Listen to me. You will swap this with this, okay? You will just swap 4 comma 5. So guys, after swapping, these bonds will get swapped, okay? And it will look like this: 5 to 2 bond, 3 to 4 bond, 1 to 1 mentoring. Come into Kumar Kesar program, you'll understand. Then 4 to 3 like this bond. Then 2 to 5 bond. Now guys, this is a good condition. Why is this good? Because 5 to 2 bond and the similar bond are now matching. See, 5 to 2 bond is matching 2 to 5 bond. You might be asking, sir, why is this good? The first number here 5 is matching the last number here 5. And the first number here 2 is matching the last number here 2. So like this, slowly slowly the reversal will become equal. Okay, clear? Now you check the second bond. Like a palindrome, guys, you just have to make a palindrome. The second bond should be equal to the second last bond. Yes, guys, second bond is equal. Second bond is 3 4 bond. So it is guaranteed that at the second last position there will be upside 4 to 3 bond. Yes, it is. And the middle one you don't need to check, right? It is odd. So guys, see, this is working. 53142, 53142, and now here it is the reverse, 53142. Hopefully you understood the whole ordeal, like how great this thing is. Okay, so guys, that is the solution to the problem. Like if I give you any array, you can now immediately solve it as a Kumar case student. For example, like if we take this also, 13242413, or let's take, this is a 1 2 bond, this is a 1 2 bond, this is a 3 4 bond, this is a 2 1 bond, this is a 4 3 bond. Here there is a 1 2 bond, so here also you want a 1 2 bond, but here there is a 4 3 bond. So what will you do? You will search where the 1 2 bonds are coming. 1 2 bonds will only come at two places only. Why will this happen? Because in the first array, if somewhere 1 is coming and 2 is coming, then 1 cannot be repeated again in this array, and 2 also cannot be repeated again in this array. So 1 might come somewhere here, and then 2 will come again, and this should also be in a bonded format. If the 1 2 bond and 2 1 bonds are not there, na, they cannot be, they cannot be transferred. They cannot be, put at the equal positions, and the numbers will never become equal in the reverse. So this is really a great problem, man. Really a nice perspective it gives to the persons trying to solve it. Okay, so that's what I was trying to say, my lovely students, is that you just need to enjoy your life. Okay, so this is not happening, so you will just search the second occurrence of 1 2 bond, which will be upside down, right? So now this upside down 2 1 bond is here. You swap it with this one. So what will happen? 1 to 2 bond, 3 to 4 bond. Then you have swapped this, right? 4 to 3 bond and 2 to 1 bond. Now this solves the problem. Why? See, 1 to 2 bond, just like a palindrome, it is matching the upside down 2 to 1 bond. This 3 to 4 bond is matching this bond. So if these bonds are matching, means everything is good. Why? यहाँ पर जो 1 2 है वो लास्ट के रिवर्स 2 1 से मैच कर रहा है. इसका मतलब यहाँ का जो पहला नंबर है वो इसके नंबर से मैच कर रहा है, ये इससे मैच कर रहा है. अगर सब ऐसे ही मैच करेगा तो इसका रिवर्स इससे इक्वल हो जाएगा ना. So that's what I was trying to say. So guys, this means what? If n is even, na, first of all you will create a hash map. See, let's say this is index I, this is ai, and this is bi. So you will create a hash map. The first number you will always write it as minimum of ai comma bi. The next number of the pair will be maximum of ai comma bi. Hash map should tell you what is the frequency of this pair. Hash map of x comma y should tell you the frequency of this pair. Okay, so guys, hopefully you understood that each pair should be coming exactly 2 times, just like the palindrome condition. Maximum only one pair can come odd time. That is only the case when the length of the array is odd, or else each pair will come even 2 times only. Why? Because there will be the, if ai is bonded with bi and aj is bonded with bj, they both will be similar, na, upside down. This ai will be equal to bj and bi will be equal to aj. So only two such pairs can exist. More than that cannot exist if both are the permutation of size n, because every number is coming one time only. Got it? Like I can show you a wrong case also where these things don't work out. Like let me show you a wrong case also. Like 3 1 2 4 5 1 2 3 4 5. So let's try to create a hash map which tells the frequency of the bonds. Okay. So 1 2 3 bond is coming for one time. This is the key and this is the value. 1 to 2 bond is coming for one time. 2 to 3 bond is also coming for one time. 4 to 4 bond is also coming for one time. 5 to 5 bond is also coming for one time. This problem can never be solved. Why? Guys, all are coming for odd times. Unless some bond comes for two times, how can you swap them? Here, swapping will make no difference. If you swap this with this, what is going to happen? 2 3 will come here, 1 2 will come here. No difference is going to happen. No difference is going to happen. Nothing is going to happen. The swapping is only useful if here, see, if this is the first number of the array and this is the last number of the array. Now, if the first number is a xy bond, last number needs to be a yx bond. Only then you can say na, that this xy is like this and here there is the reverse. So if there is a 1 3 bond, there needs to be a 3 1 bond in the array. If there is not, you cannot solve the problem, beta G. So let me show you one more example, lovely student. This is a very heavy data structure problem. You should know how to declare and construct different kind of hash map of pairs and many more things. You will have to store the indices also of the two type bonds here. For example, 25134, 25134, and then we go to 35412. 35412. Okay. Now let's create the hash map, right? Which tells us the bond status. So now 2 3 bond is there, right? 2 3 bond is coming for one time. Then 5 to 5 bond is also coming for one time. Then 1 to 4 bond is also coming for one time. But guys, 3 to 1 is nothing but, okay, did I write it wrong? 25134, 25134, 35421, 354. Okay, I wrote it wrong. Yeah, in the hash map, what will you write? The 2 3 bond, right? Key and the value. The 2 3 bond is coming two times, here also, here also. So you can say 2 3 bond coming two times. 5 5 bond coming one time. And 1 4 bond is coming two times. See now, 1 4 4 1 are just conjugates of each other. So see, each bond should come for two times only. Only one bond can come for odd times. Why? Because that you can put in the middle, right? You know that 5 5 is coming here. You can put 5 5 in the middle and get the job done. So if you swap, it will look like 2 3 1 4, then 5 5 in the middle, then 3 2 and 4 1. Now how to solve this problem? The first bond is 2 3 now. So you want 2 3 here also. So just search for the second occurrence of 2 3, it's here. So swap this with this and the problem is solved. 2 3 1 4 5 5, then 4 1 and 3 2. So guys, like this, if the array is of size n now, you will travel from 1 to n by 2. You will check which bond is here. Try to make sure that the same bond is here also. If not, do the necessary swap. Find the second occurrence of this bond in this array and do its swap with the nth element. Then do the same for the second element. Try to find the necessary, like its other partner in this array and make sure you swap it with the n minus 2 element. Like this, you fix the first half, the other half will automatically get fixed, right? Because just like a palindrome, more than a reverse, you're trying to create a special type of palindrome which is generating the reverse of the permutation, which is generating the same effect as the reverse of the permutation. Lovely, lovely, lovely. Done, 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 done. So if you want regular problem solving videos like this by me, let me know in the Google chat. Not in the Google chat, like I teach in the Google Meet now, so many times that's my habit to say. So no problem. Anyways, so let's get in here. So guys, it's see, array A, array B I took in, right? Yes, sir. When both the numbers are equal, na, something special happens. So make sure you note down its index, okay? Both the number equal status does happen. Without it, the problem will not work. In the odd case, if the odd case is valid, the two numbers should match. Like, see, 5 5 was matching here, 5 5 matching here. So that is the basic requirement. If you deep dive, you will understand. Anyways, what is the pair? Why am I writing minimum of AIBI and maximum of AIBI here? To make sure I can keep a track, because writing making two pairs x comma y and y comma x is wastage of space. When 2 comma 3 bond is coming, your map will say that 2 comma 3 is coming one time, and when 3 comma 2 will come, your map will say that 3 comma 2 is coming one time. This is wastage. Don't do it like this. You should just know that 2 comma 3, even if it reverse is coming, you consider that also as 2 comma 3 only. That's why no matter what the numbers, whatever is the minimum of both of them, that is the first value, and whatever is the maximum of both of them, that is the second value. Done, done, done. So where, so minimum you can see, right? Ram Ram. Life is so interesting. You just need to know how to enjoy your life, okay? So min, max, x comma y pair, and the bond frequency also taken. Now we'll just check what is the frequency. If all the guys are even or two, good. But if even a single guy is odd, you increase the odd frequency. Odd frequency should be maximum one. If more than one, then the answer is minus one. Done, 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 done. Now, if the length of the array is odd, na, please make sure that there will be this special odd case, and in the odd case both the elements will be equal. If the middle elements are equal, good, do nothing. But if middle elements are not equal, swap them with the two elements which are equal. This case I leave it up to the reader who is watching. They will understand what I'm trying to say. For example, in this case, you can see now there is a 5 5 here. You need to swap this 5 5 with the middle guy, right? Because n is odd. So same thing I'm doing here. Middle guy needs to be swapped with equal guy, so they don't create problem later on. And now guys, just travel and travel the array, and whenever you find this AI BI pair, na, there will be two occurrences only of this in the whole array. So the first occurrence you store here, and the second occurrence you store here. Okay, so you create a special type of hash map for that. It's called as this hash map, like pair LL hash map one bond bond bond. So it's a bonding going on. Okay, chemical bonding we used to study in chemistry during the JE times, right? So guys, once the bond is done, then finally you travel from 1 to n by 2, guys. You get it done. You find its second occurrence of this bond. You swap it with relevant bonds, and you update in the respective hash maps what's going on. There is some tricky cases here. Huh? Be careful, or you can screw up. And after fixing everything, guys, this starts working. Done, 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 done. Nice. So hopefully you guys enjoyed this class from me. With the name of God, Ram Ram. Always have the strength and power in your life with the name of God, Ram Ram.